Dear friends, so in the previous videos we have discussed about the causes of the cracks, that is the introductory part. So greeting of the day, myself Dr. Trilok Gupta. Today I will discuss about the principal causes of cracks. Basically, only I will discuss in this video the due to the moisture change, because this is a very vast principle to form or to causes the crack. So for prevention or minimizing the occurrence of the non-structural cracks, it is necessary to understand the basic causes and mechanism of the cracking and certain properties of building material which may lead to dimensional change of the structural components. The principal mechanism causing non-structural cracks in the building are, that may be the moisture change, thermal movement, elastic deformation, creep, chemical reaction, foundation movement, and settlement of soil, growth of vegetation. Now, in this video, we will discuss this causes of the cracks due to the moisture change. So, the moisture change, these cracks due to the moisture change may be due to this various types. So most of the building materials, that may be the concrete, mortar, bricks, timber, and are porous in the structure and in form of the intermolecular spaces, and they expand on the absorbing moisture from the atmosphere and shrink on the drying. And these movements are reversible. Reversible means when it will dry, it will shrink. When it will absorb water, then it will expand. So sorry, so that is cyclic in nature and shrinks on cycling in nature, and are caused by increase or decrease in the interpore pressure with the moisture change. Extent of the movement depends upon molecular structure and porosity of a material. Apart from reversible movement, certain material undergoes some irreversible movement due to the initial moisture change after their manufacturing or construction, and the incidents of irreversible movement in material are shrinkage of the cement and lime based material on initial drying, that is the initial shrinkage, plastic shrinkage, and that may be the expansion of the brick or other clay products on removal from the cleans, that may be the called as the initial expansion. So in this video, we will discuss all these factors that will be that is the part of the moisture change, and that is basically responsible for the cracks in the structure. So first of all, reversible movement. Depending upon the extent of the reversible movement with variation is the in the moisture content, and various building materials are classified as the small movement, that is the let's say clay bricks, igneous rock, limestone, marble, gypsum, plaster. So these materials does not require much more precautions. In the next category, that is the moderate movement, so concrete, sand, sand lime brick, that is a sandstone, cement, lime mortar. So these materials require certain precautions in the design and construction. Next type is the large movement, that may be the timber, blockboard, plywood, wood, that may be the cement product, asbestos, cement sheet. These material requires special treatment at joints and protective coat on the surface. Now, initial shrinkage. Basically, this initial shrinkage, which is partly irreversible, normally occur in all building material or components that are cement, lime based, and is the one of the main causes of the cracking in the structure. Initial shrinkage of the concrete and mortar occurs only once in the lifetime, that is at the time of manufacturing or construction, when the moisture used in the process of manufacturing or construction dries out, and it far exceed any reversible movement due to the subsequent wetting and drying, and is very significant from crack consideration. Now, this based on this based on this initial shrinkage, there are the so many factors responsible for the initial shrinkage. First is the cement content. Basically, this we will discuss one by one. So this cement content, as a general rule, richer the mix, if there is the much more greater quantity of the cement, then definitely there will be the greater the drying shrinkage. So with the help of this figure, we can observe if there is the rich mix, then definitely there will be the more percentage of the drying shrinkage. But when we uh, reduce the quantity of cement from the mixed mortar, definitely there will be the less drying shrinkage. So this graph shows the relationship between the mixed proportions and the drying shrinkage of the cement, cement concrete or cement mortar. This next figure shows the effect of the water cement ratio on the drying shrinkage. Again, from the figure, we can observe if we increase the water content in the concrete or in the mortar, definitely there will be the more percentage of the drying shrinkage. With the increase of the water content in the concrete or mortar, drying shrinkage will increase. So this figure shows the relationship between the water content and the drying shrinkage. Now, this figure shows the effect of the size of aggregate on the water requirement. When we use the this higher or maximum size, or we can say that the bigger size of the aggregate, definitely we require the less quantity of water. But if we using the less size of aggregate, that is, we generally use the 10 to 20 aggregate size, then at that time we required the much more water as compared to when we are using the 40 or we can say that the 60 aggregate or 100 aggregates. So this again affects the cracking in the concrete, because if suppose water, much more water is present in the concrete, definitely due to this previous slide. So if the water is increased, then drying shrinkage will increase. So the effect of size of aggregate is much more affects the shrinkage or cracks in the structure. Now, next is the effect of temperature on the water requirements. From the figure, again we observed that if suppose our ambient temperature is greater, then we required the water, much more water. So this again affects the our water requirement uh, uh, in the concrete or in the mortar. So that is again temperature is responsible for the this drying shrinkage or cracks in the concrete. Now other now we comes to the previous slides. There are the other so first three we have discussed. Now next is the use of accelerator. Basically, use of the calcium chloride as accelerator in the concrete appreciably shrinkage increases, being up to the 50% with the 0.5 to 2% addition of the calcium chloride. That means if we are using the calcium chloride from 0.5% to 2%, then there will be the more 50% more shrinkage in the concrete or in the mortar. So we have to use this accelerator carefully. So and we have to take care so that this shrinkage cannot increase up to 50%. So moreover, it has some corrosive effects on the reinforcement in the concrete. This calcium chloride has the some corrosive effects also. Now the curing. Basically, this curing also plays an important part in the limiting shrinkage. If proper curing is started as soon as initial set has taken place and it continued for at least 10 days or 14 days, this drying shrinkage is comparatively less because when hardening of concrete take place under moist environment and therefore is initially some expansion which offset a part of subsequent shrinkage. This we can use this stream curing of concrete block at the time of manufacturing reduces their liability of to shrinkage as high temperature results in the this pre-carbonation and this now next is the presence of excessive fines in the aggregate or concrete or mortar. So presence of this excessive fine that may be the silt, clay, dust in the aggregate has considerably effect on the extent of the shrinkage in the concrete, and presence of fine increases specific surface area of aggregate and consequently the water requirements and therefore, specifications for fine and aggregates for concrete lay much emphasis on the cleanness of the aggregate, and we have to take proper precautions that excessive fines in aggregate should not be present. Next is the chemical composition of cement. Now, chemical composition of cement used for concrete and mortar also has some effect on the shrinkage, and it is less for cement having greater proportions of this calcium silicate and lower proportions of this alkalis like sodium and potassium oxide. Rapid hardening cement has greater shrinkage than ordinary Portland cement, that is the OPC. And next one is the temperature of fresh concrete and relative humidity. Basically, an important factor which influence the this we have discussed in this next uh, this. So an important factor which influence the water requirement of concrete and thus it shrink in temperature for of the fresh concrete. So now we comes to this hmm, plastic shrinkage. Basically, what is the plastic shrinkage? So basically in the this fresh concrete, then sometimes crack occurs on the surface before it harden, and immediately after placing the concrete, solid particles tends to settle down by gravity action and water rises to the surface, and this process known as the bleeding, that is produces a layer of water at the surface, and this process continuously till concrete has hardened or set. As long as the rate of evaporation is lower, then rate of this rate of bleeding, there is a continuous layer of water at the surface, this known as the water sheen, and the shrinkage does not occur. But when the concrete surface loses water faster than the bleeding action, bring it to the top. Then shrinkage of top layer takes place, and since the concrete in plastic state can't resist any tension, and cracks are developed on the surface, and these cracks are generally common in the slabs because it is exposed to the temperature and it has larger area, and the extent of the plastic shrinkage that depends on the temperature of concrete, how much is the temperature of concrete, and exposure to the heat from the sun, this radiation, and relative humidity of the ambient air and velocity of the wind. So these are the factors that basically responsible for the plastic shrinkage cracks. Then this is the next one is the plastic settlement cracks. Basically in the fresh concrete of the reinforcement structure, sometimes cracks also occur on the surface before concrete has set. when there is a relative high amount of bleeding and there is some form of this obstacle to downwards sedimentation of the solids, these obstacle break the back of the concrete above them, forming the voids under their belly. These cracks are normally observed basically over the formwork that tight bolts or over reinforced near the top of the section in narrow columns and wall due to the obstacle of the sedimentation by resulting this arching action of the concrete due to the narrow passage and at the change of the depth of the sections. So we can observe these from the figures that this is a plan and this is a detail, and if suppose there is the steel present and there is the voids, and due to this plastic settlement the cracks will be developed, and this is the large view of this figure how the cracks is formed due to this plastic settlement. Now initial expansion, when the this our clay bricks are fired during manufacturing, due to the high temperature, not only the intermolecular water but also water that form a part of molecular structure of clay is driven out after burning. As temperature of the brick fall down, the moisture hungry bricks starts absorbing moisture from the environment and undergoes gradual expansion. Bulk of this expansion is irreversible, and from the this practical purpose, it is considered that this initial expansion ceases after first 3 months, and we can use of such bricks before this cessation of this initial expansion in brickwork will cause irreversible expansion and may lead to cracking in the masonry. So this is a small example of this initial expansion. Basically, this A wall, basically this end of wall has due to the expansion, or we can say that the oversailed at the level, and this push the wall of this B, and again this C wall is also expand. So this small expansion will create the torsion, and this B wall separate out from the A and B wall. So this is all about the cracks due to the moisture change. So I have used the references to making these videos are the SP25, that is the handbook on the causes and prevention of the cracks in the building. The publishers is the Bureau of Indian Standard, and I have also used two other references, that is the Principle of the Modern Building 1961 volume 1 and Her Majesty Stationery Office, London. And next one is the Control of Cracking in the Concrete Structures. That is the report of the ACI Committee 1972 to 24, published in the ACI journals. So thank you, friends. So in the next slide, we will discuss the cracks due to the other causes. Thank you.